And we'll be continuing the discussion on psychiatric illness in precision neuroscience. And I'm pleased to introduce our first speaker, Dr. Warren Bickel. Warren is the Virginia Tech Carilion Behavioral Health Research Endowed Professor. He's the director of the Addiction Recovery and Research Center here at the Virginia Tech Carilion Research Center, and also a professor of psychology at Virginia Tech. Warren.
Thank you, Pearl. What I'd like to do today is share with you a concept, a process, a measure that reveals how things change. And I think that it could provide insight to Dr. Wood's earlier discussion about the failure of CNS drugs, because this process, if not understood, can mask important differences. And I hope to reveal that to you. But I'm going to focus with it on impulsivity, which is a key measure, but I think it's much broader than that. But I'm just doing it so we can concretize a certain domain. So first, impulsivity is a multifactorial construct that refers to a tendency to act on whim, displaying behavior characterized by little or no forethought, reflection, or consideration of the consequences. It's been implicated in a wide variety of psychiatric disorders, mania, personality disorders, ADHD, substance use. It's often a target for intervention, and it's measured with a variety of tasks. I'm going to particularly focus on temporal discounting because it's my favorite measure of impulsivity, but this process cuts across multiple processes that measure impulsivity. So let me just describe delay discounting, and then we'll get into how these things actually change. So delay discounting refers to the reduction in value of a reinforcer as a function of the delay to reinforcer delivery. We all discount to some extent. It's a sort of a measure of our ability to delay gratification. Just to illustrate it, I'm confident if I was to ask all of you, what would you prefer, $1,000 now or $1,000 a year from now? I bet you most would say, I'll take $1,000 now. I'm in Roanoke, I could have a wonderful time, have money left over. If you would make that choice, that means the later $1,000 is not worth as much as the current $1,000. It's discounted. And we can find out how much by doing this process. We do it by doing psychophysical procedure, where we change one of the stimuli and wait until the subject tells us that they notice a difference. Let me illustrate. So we'll say, what would you prefer, $1,000 now or $1,000 a month from now? And still probably most of you would prefer $1,000 now, unless you had a particular bill coming up in a month that you were very focused on. But what if we said, what would you prefer now, $950 now or $1,000 a month from now? $900 now or $1,000 a month from now? If you would switch your preference from the immediate to the delayed option at $800, we can infer that you discount $1,000 by 20%. If we do this across a broad range of time frames, 1 week, 1 month, 6 months, 1 year, we can construct a curve, and that curve has a particular quantitative structure that is well characterized by this equation, where the value of a reinforcer equals the amount of reinforcer divided by the sum of 1 plus the discount rate multiplied by delay. Let me just make this equation concrete to you. If I want to increase the value of a reinforcer, I could increase the amount of it. I give you have more money involved. I could decrease the delay, or if I was like Janet Yellen, I could change the discount rate, and I would decrease it. The K parameter is what often we solve for when we're doing this analysis. On other times, we do area under the curve. All right, so let me jump into the process we're interested in here. Is there a signature of change? I think understanding change will require moving beyond simple increases and decreases in the target behavior. And that raises the question, is there a signature of change that can inform the direction and magnitude of change? Well, if you dig back into the literature, there is this guy, Joseph Wilder, who proposed the law of initial value. He said the direction of a response of a body function to any agent depends to a large degree on the initial level of that function. The law of initial value has turned into what we now call baseline dependency. Let me illustrate one of the first demonstrations of this. Peter Dews at Harvard was one of the first people to discover this. He was in the Department of Pharmacology. Here he's looking at phencyclidine, and here we've got the baseline rate of some pigeons responding on an operant task, and then we're looking functionally at the proportion of change as a function of different doses of phencyclidine. What I want to point out to you with the higher dose is that here we have subjects that are high rate, but if they're below this line, phencyclidine reduced the rate of responding. But look over here. Animals that were responding at a low rate showed increases in responding. And there are subjects in between that showed little or no change. That is an orderly, regular process that occurs frequently without people taking acknowledgement of it. And I'm going to show you how that can cause trouble and why it means something for precision medicine. But just to show that it's not just related to pigeons responding to operant tasks, here's a really cool study from Rappaport, 1980, Archives of General Psychiatry. This was a field that they put people in a room with nothing that they could sit down on for 2 hours and measured their activity. And they had hyperactive boys, and this is how much they would respond in the 2 hours. And then when they were given amphetamine, we see this huge decrease in their responding. Normal boys don't move around as much, and you see a much smaller response. And adult men don't seem to move very much at all. So what I'm saying is there is an order relationship with change that's tied to the baseline level of behavior that would be characterized by this hypothetical function. Now, you may immediately be saying to yourself, well, isn't this just regression to the mean, right? The high go low, the low go high, and it's not. And fortunately, Oldham discovered this method. I'm not going to go through this equation, but if anyone wants to talk about it later, we can. Where we can test for baseline dependence by eliminating the biases inherent in correlation between pre and post. That is, this equation allows us to distinguish between regression to the mean versus true rate dependence, and also eliminates the mathematical coupling of measuring the same individual under two circumstances. So we were very interested in thinking about this and how broad this phenomena was. So we did a review and reanalysis. We found a bunch of studies that were either amenable to analysis, or we were able to get the original investigators to give us the actual data so we could reanalyze it. And we looked at it both at a preclinical and clinical level. Just here's an example. Winstanley, she looked at the effects of different doses of amphetamine. She's actually looking at the same discounting task, but done in this case in rats. And what you see was, as the dose gets higher, this rate-dependent effect seems to actually get more pronounced. So in our review and reanalysis at the preclinical level, we found 19 of 20 instances showed baseline dependence in individual data sets, and 26 of 33 showed effects consistent with baseline dependence when we could only look at the median splits of the subjects, which is the only thing they had published. So we thought that was pretty interesting. And we said, okay, what's happening at the clinical level? Well, here's a paper by Schmal, once again looking at discounting, here in this case area under the curve. And what you see is that the placebo baseline seems to be related in part to the response that is obtained. And we have this relationship here. This is our analysis of their data, right? This isn't what they presented. And indeed, when we look at the all the clinical data, 5 of 15 instances showed baseline dependence in the individual data sets, and 5 of 5 that once again all we had was median splits to base it on, looked consistent with rate dependence. And just to summarize that, so across all the studies, 67% of the total data sets were baseline dependent, and 77% of the baseline dependent effects were observed with the highest dose examined. This was observed with amphetamine, methylphenidate, modafinil across a broad set of measures. Now let me tell you why I think this is important for precision medicine. Here's a study by Atchison and DeWitt. DeWitt's a good friend of mine. They were looking at the effects of, I think, bupropion in this case, and they were looking at a slightly different task called the BART, the Balloon Analog Research Risk Task, where somebody pumps up a balloon, and you have to, every time you do it, you get some money, but if it blows up, you don't get any money, right? So it's a sort of a risk task. And what you see is that the effects of bupropion is not different between the two groups. That could be just like all the CNS studies that were talked about by Dr. Woods, or some portion of them. But is that really the way it worked? Well, we got the data, and we found rate dependence. So we can identify heterogeneous responding, but it's an orderly function of the baseline level. And if it's an orderly function of the baseline level, that means we can identify for whom we will see a therapeutic response, whom we will see a contratherapeutic response, and who will show no effect. Indeed, we can start to predict treatment response. The question to answer that effectively requires that if we were to keep on retesting this effect, that the inflection point between increases and decreases remain constant. And that's an empirical question that is yet resolved. Some of these measures, such as discounting, are highly replicable, so I suspect it may be the case, but we need to prove that. And just to show you this is not just limited to the level of behavior, there was a recent paper published in Alcohol and Clinical Experimental Research that did TMS in alcohol-dependent individuals while they were inpatient, then followed them outpatient, and they found that there was a rate-dependent effect in the ACC. So here's the response to the TMS treatment, baseline levels, before TMS treatment, and here's the change after TMS. And what you see here is they followed them up, and they found which individuals continued to abstain after the hospitalization and who relapsed. And you can see that individuals who tend to show an increase in AAC activation seem to relapse, while the individuals that either showed no effect or decline did not. I think this is very exciting. It may mean that this process applies not only to behavior, but to actually the way that the brain changes when a particular agent is attached to it. I'd like to now just show you that this is related to things completely independent of drugs and is relevant to the problem of addiction. So here are 5 studies, and these are all studies that I conducted. And I had 2 studies with heroin-dependent individuals where they received a really multimodal treatment, right? They received medication, buprenorphine or Suboxone as it's called. They received cognitive behavioral therapy, and they also received contingency management, where they're reinforced for their abstinence. We would collect urine samples 3 times a week, and if they were drug-free, we would give them money, right? We had a study where we had working memory training in cocaine-dependent individuals, and we have the control condition for that, and we wanted to see if working memory would change discounting. I had a standard trial of tobacco treatment, and it was just a very standard treatment. And then we had treatment for stimulant-dependent individuals that, in retrospect, was not highly efficacious. So I got this discounting measure at baseline, and I got this discounting measure after the treatment. And here's the data. So with the 2 opiate-dependent trials, we see very strong rate-dependent effects. With the working memory training, we see rate-dependent effects. The control working memory training shows nothing, and the stimulant treatment showed nothing. This may look rate-dependent, but actually this qualifies as regression to the mean, so we can eliminate that for consideration. If you do median splits, and if they cross the line, they're not statistically different, and you see in each of these cases, the individuals that discounted the most benefited the best from these interventions, while individuals who discounted not as much showed no response. Now, in 4 of these trials, I actually have measures of efficacy. That is, how good during the treatment, how many of the urine samples were drug-free, right? Clearly objective, straightforward measure that I can summarize and use across these different forms. Let's just see what that relationship is between that and whether we got a significant change in the overall group in discounting. So here are the 2 opioid-dependent trials, and the percent of scheduled free targeted samples in them was substantial, right? 80, that's a little around 90% there. And if they don't cross this line, that means the discounting change from pre to post was significantly different. It changed. Now, one thing I'll tell you is, another thing we know about discounting is for a bunch of treatments that are moderately effective, it looks like the baseline by itself, not looking how it changes, predicts treatment outcome. And indeed, in this particular trial, discounting at baseline predict how well a particular individual did. The people that discounted the most did the worst. The people that discounted the least did the worst. You're not changing how much they discount. Just what they bring to the table influences the treatment. And in this particular treatment, nothing was going on. So this raises an interesting relationship between this measure of rate dependence and treatment effects that, let me suggest it in a theoretical slide or hypothetical slide here. So what we've seen is when you have a highly efficacious treatment, this measure of impulsivity changes rate dependently. For moderately effective treatment, baseline discounting predicts treatment outcome, but discounting itself is not changed pre to post. And if you have treatments that don't work, you don't observe either of those relationships. I think this opens the box in a certain way, in several different dimensions, that rate dependence could provide an understanding of, 1, who will succeed in treatment. It could actually determine the cutoff points, if we can get those stable, to identify which people respond in the appropriate direction, which I think could be very exciting. So I'm just going to conclude by saying baseline dependence is a seemingly robust phenomena in both clinical and preclinical applications. It can be observed in different populations with different measures of impulsivity and with different types of interventions, both drug and non-drug. Can identify hidden heterogeneity and can be used to identify who will be responsive to the intervention. It strikes me that the pharmaceutical company that is able to harness this may find that those CNS trials that were ineffective were masking heterogeneity, and that there could be a subgroup that could be highly influenced by their treatment. I'd like to just thank my team and my funders. Thank you very much.